So we're going to talk about AI, we're going to talk about rendering, and we're going to talk about simulation. We're going to start with artificial intelligence. And one of the founders of modern computer science was a Dutch systems scientist, programmer, software engineer. Held a long-term seat at the University of Texas at Austin, Esker Dijkstra. He was also a fountain of quotes, and one of his best was, "The question of whether a computer can think is no more interesting than the question of whether a submarine can swim." I mean, the reality of it is, whether it's carbon-based, humans, other organisms, or silicon, or a material yet to be discovered, there's no intrinsic reason in either mathematics or physics or computer science why a computer shouldn't, in theory, be capable of thought. Could we give them the next slide, please? Across the animal kingdom, a wide array of creatures have developed high degrees of intelligence. If you go back 700 million years ago, the last common ancestor of humans and the cephalopods, octopuses, squids, nautiluses, was a small worm-like organism with eye patches. Cephalopods, highly intelligent. Octopuses in particular are notoriously known for being the escape artists of the animal world, the Houdinis, if you will. One octopus at the Santa Monica Pier Aquarium even was able to figure out how to deliberately mess up some water release valves and flooded a significant portion of the aquarium. If you look at birds, class Aves, particularly the corvids, which are birds like ravens, blackbirds, magpies, highly intelligent creatures which have the ability to use tools in some instances that surpass those of primates. Dogs, man's best friend, were recently discovered to process language using the left and right hemispheres of their brain, much as humans have done. We've coexisted with dogs. There's quite a contentious scientific argument about that, anywhere from 15 to 40,000 years. We've been in very close proximity to one another, significant evidence that they understand a significant amount of human speech. It's interesting to note that Amazon recently announced they were developing an AI product to help humans communicate more effectively with their pets. Cetaceans, the whales, dolphins, and porpoises, highly intelligent, highly social creatures, not tool users, but very sophisticated pack hunters in some of the predatory species. Primates, our closest living relatives, such as the chimpanzees, specifically Pan troglodytes, again, highly sociable, highly intelligent, capable of tool use, and even display signs of culture, different behavior from band to band of chimpanzees in the wild. Just as intelligence has conferred an adaptive advantage on these kind of creatures, AI will confirm a huge advantage on businesses that embrace it and utilize it. And at the risk of making a prediction, I'll say in 15 or 20 years there'll be two kinds of businesses: those that are still in business and utilize artificial intelligence, and those that are no longer in business because they didn't. Could we go to the next slide? Really, Homo sapiens' essential differentiator from any other creature on the planet is the fact that we've been able to develop a technological intelligence. Cetaceans, for example, are clearly capable of symbolic reasoning. Some birds are, primates are, but humans have had the ability to take that symbolic reasoning and turn it into a technological intelligence. It's taken us to planets. It's taken us beyond the boundaries of the solar system. We're not going to solve the problem of consciousness in this presentation, but arguably the human brain is one of the most complex known structures in the universe. 106 billion neurons, 1,000 trillion synapses, connections between those neurons. The thalamocortical brain network, which is widely associated to be very important to the consciousness, the sense of self-awareness in humans, is a relatively small number. So not only can computers potentially think, but given sufficient, advances in technology, potentially they could even become, for lack of a better term, self-aware. Could we go to the next slide? Where do we stand today with artificial intelligence? And I want to kind of differentiate a couple of terms. There's artificial general intelligence, which is building a machine that would display intelligence much like a human's. You've probably heard of something called the Turing test, where you take a human and a computer and you have them communicate, and if the computer and human, after they communicate, the human can't tell whether it was talking to a computer or a human, that machine would be considered intelligent. Well, there are variants of that methodology, and some researchers went in and ran the equivalent of an IQ test on Google, Baidu, Microsoft Bing, and Apple Siri in 2017. And Google showed an IQ of 47.28, Baidu 32.92, Bing just under Baidu, Siri kind of a laggard. So Google's IQ is actually slightly below a 6-year-old human's. Those of you with children know that a 6-year-old human is capable of a lot of very interesting behavior. Overall, however, AI's IQ, as best we can tell, is significantly lower than an 18-year-old's average score of 97. What's important here, though, is to look at the rate of increase, because in 2014, the same research group looked at Google's IQ and Baidu's IQ, and it was only 26.5 and 23.5 respectively. So Google's IQ has grown 78% since 2014, Baidu's 40% since 2014, and there's no sign that these trends are flattening off. If anything, they're picking up. So artificial general intelligence in terms of the social media, the search platforms such as Google, technologies such as Bing, technologies such as Siri, which are ubiquitous across devices ranging from cell phones to smartwatches to even speakers or other home automation devices, is rapidly advancing. Could we go to the next slide? The GV100, based on NVIDIA's Volta architecture, really is the platform on which NVIDIA is building their AI rendering and simulation efforts. The GV100 is the first Quadro product based on NVIDIA's Volta architecture. It's the most sophisticated GPU NVIDIA has ever built, 21.2 billion transistors, uses the latest process and manufacturing technology from Taiwan Semiconductor Manufacturing Corporation. Could we go ahead and do a mute and unmute, Willie?
Yes. Your call is very important to us. Thank you for holding.
Carl.
I apologize for that brief delay. I don't think you want to hear PNY's sound loop. It uses a custom 12-nanometer FinFET process, 815 millimeter square die size, so it is a very large chip, but it provides unprecedented mixed-mode compute capabilities, and we're going to be discussing the implications of those in the AI portion as well as the rendering portion and simulation portions of this presentation. A very significant addition is a new type of core. You've heard of CUDA cores. These have been FP32 graphics cores, in some instances FP64 cores for double precision floating point, which are ideal for simulation or computer-aided engineering. Tensor cores are primarily optimized for artificial intelligence, deep learning, machine learning applications. They can operate at mixed precisions, although they primarily are used for FP16 or half precision. They're built for something called matrix arithmetic operations, where you take a 4x4 matrix, perform some multiplication operations on it. It's a kind of a foundational mathematical function of AI and deep learning algorithms. You can do 64 of these floating point, fuse, multiply, and accumulate operations per clock cycle with the chip. You can perform 1,024 individual floating point operations per clock cycle. This has never before been available on a Quadro chip. On the memory front, unprecedented GPU memory capacity, 32 gigabytes. This blows past the P6000, which offers a 24 gigabyte GPU frame buffer, GPU memory. Tremendous improvement in bandwidth thanks to the HBM2, 870 gigabytes per second of peak bandwidth. High bandwidth 2 memory intrinsically offers error correction control without a performance and capacity hit, unlike GDDR5 or GDDR5X. So if you need this for engineering calculations, scientific and technical work, you can turn it on without taking a performance or capacity hit. Ideal for low latency and very large data sets, which are what you find in rendering, what you find in AI, particularly deep learning applications, also in simulation. Finally, mixed precision. This GV100 GPU can handle FP32, FP16, and 8 instructions simultaneously, has a 16-bit floating point operation through the Tensor Cores optimized for deep neural networks, has independent and parallel integer and floating point data paths because AI also uses integer operations, something known as int8, for inferencing, which is a fancy way of saying making a decision. And the voltage streaming microprocessor architecture can efficiently manage workloads involving all of these different modes, these precisions, FP64, FP32, FP16, int8. Could we go to the next slide, please? Every segment you folks currently sell Quadro into will benefit from AI, better rendering, and simulation. Examples abound. Manufacturing, the ability to turn CAD drawings directly into photorealistic renderings. On the AI front, something called generative design, the use of AI algorithms to go in and take a design that a human engineer has created and optimize it would be an example of that. The prodigious floating point 64 performance means that you can do CAE calculations much faster, lower cost than ever before. In the media and entertainment space, we'll be talking about the ability to do real-time photorealistic rendering, a huge advance for folks in any aspect of pre-visualization or pre-production or post-production of movies or television. In automotive, AI obviously plays a huge role in autonomous vehicles, but generative design also comes into play when you want to do something like lightweighting, making components of an automobile lighter in weight so they can generate greater fuel efficiency. Or even simulation comes in. If you look at electric motor design for electric vehicles, a lot of work is being done using computational electromagnetics to make electrical drivetrains more efficient. In AEC, rendering particularly is instantiated in virtual reality, is helping architects optimize spaces to make the buildings people are working in more productive or to identify potential design flaws before construction is started. In the energy domain, oil and gas, AI is being used to automate the evaluation of seismic survey results. If you look at other forms of energy, for example, simulation and AI are being used to evaluate techniques to smooth out plasma kinks in potential fusion reactor designs. In scientific and technical computing, everything from particle physics to drug discovery in pharmaceuticals, benefits from better rendering, AI being applied to it. Healthcare, we already have AI systems that are better at evaluating medical imagery than some of the world's foremost specialists in the field. And we're finding some very surprising abilities of AI to use data that are easily collected to predict other types of conditions. Google researchers, for example, recently published a paper showing that photographs of your retina, which are a staple of appointments with your eye doctor, can be used to predict a variety of cardiac conditions. So this is going to be a profound transformation across all the segments you folks sell Quadro into. Could we go to the next slide, please? Now, if we look at the product line, there are a couple recent additions, the P620, an entry-level card, which we won't talk about today, but the GV100, the highest-end Quadro ever built, we will be talking about in great detail. It's important to note that the GV100 stays in the line. If I could have Willie go to the next slide, I'd like to make another point, which is for the first time in history of the Quadro product line, the majority of the cards feature the rendering horsepower, the capabilities to do VR, which goes from the P4000 all the way up through the GV100. If you move up to the product stack, the GV100, adds capabilities such as NVLink, which we'll discuss in more detail soon. Could we go to the next slide? So let's drill down into some of the technical specs on the GV100. The core positioning of this card is reinventing the workstation for AI and rendering. And one of the standout features of this board is NVLink. NVLink is an extremely high-speed interconnect that allows you to effectively, lack of a better way of saying it, Vulkan mind meld two GV100s together into a single logical entity. Could we go to the next slide? There are a lot of advantages to doing this. For starters, you effectively double the CUDA core count, the Tensor core count, and the available GPU memory up to 64 gigabytes. You do this at extremely high speeds, up to 200 gigabytes per second of bidirectional bandwidth. This is a 25% improvement over the speed of NVLink as implemented on the prior generation GP100. It's used in pairs, so NVLink connectors are sold in kits of two. Two connectors connect the two cards together. Some of you in the VizSim space, if you have GV100s and you use NVLink, it hardware synchronizes up to 8 displays. So if you're working with 8 displays in this context, you don't need a Quadro Sync 2 card to get all the benefits of hardware gen lock or frame lock functionality, and it also implements full SLI functionality for GV100 boards. So for example, 128x full scene anti-aliasing for those of you in the rendering space. Next slide, please.
Yeah, and I just want to add to the NVLink information. As everyone is aware, like if you're using Quadro Sync, like Carl stated, you can use NVLink instead, and you can still get the Mosaic mode capabilities. But to get the advantage of the 200 gigabits bidirectional bandwidth, it's not like SLI or Mosaic mode. It's not something that you have to just click and enable and configure. You will have to do peer-to-peer configuration via NVIDIA software. So if you have questions or details how to accomplish this, let us know, and we can point you to the right resources and how to set it up.
Yeah, that's a great point, and I should also indicate there is an NVLink API that the software needs to support, so it can direct I/O between the cards over NVLink as opposed to PCI Express. It's not a terribly complex or difficult API to implement, and we're seeing a lot of folks in the rendering space, simulation space, and the science and technical market space take advantage of it, as well as the AI development frameworks. Could we go to the next slide, please? So here are a few more of the technical specifications for the GV100. If you look at the CUDA core count from an FP64 perspective, double precision, 2,560 cores. If you look at it, FP32, which is mostly graphics, specifically rendering, 5,120 FP32 cores, and 640 of the AI-optimized Tensor Cores. Memory capacity we've touched on the memory bandwidth. If you look at the raw compute performance, FP64 is 42% better than the GP100. FP32 performance is 44% better than the GV100. You really can't compare FP16 because the GP100 didn't have Tensor Cores. It could do it, but it's like bringing a, lack of a better phrase, a knife to a gunfight. It simply didn't have the hardware to play in this space the way the GV100 does. If you look at INT8, a 26% improvement. The system interface for the card, Gen 3 PCIe by 16. We've discussed NVLink's bandwidth. The display capabilities are formidable. The connectors on the back of the card are for DisplayPort 1.4 with the latest implementation of high-definition content protection, HDCP 2.2. Drive 4K, 5K, even dual 8K displays at 60 Hertz refresh rates with high dynamic range imagery. Yes, the card supports VR, and it also supports stereo through a 3-pin connector, and a stereo connector bracket is included with the card. So those of you that need professional 3D stereo capabilities, it's there. Could we go to the next slide, please?
Yes. A note on the 8K support, in order to achieve and run the two of them at 60 Hertz, you will have to utilize 2 display ports per panel to achieve the 60 Hertz.
Okay, so I threw up these numbers on the prior slide. I just wanted to kind of put them in front of you again, and Willie, could you click on the next slide? Because they have very different uses. FP64 is primarily of interest to those that are doing simulation or computer-aided engineering. Raw FP32 performance, of course, is foundational to graphics, but plays a tremendous role in photorealistic rendering. FP16, AI, deep learning, machine learning, and the N8 performance, AI, deep learning, and machine learning. So this card, from a compute point of view, supports all the major graphics use cases, as well as all of the artificial intelligence, deep learning, machine learning use cases you and your customers will encounter. Next slide, please. If we did a gen-to-gen, GP100 to GV100, obviously we've moved on to Volta, so the most powerful, power-efficient AI-equipped GPU NVIDIA knows how to build. We've discussed the performance advantages in terms of raw compute, the memory performance advantage, the display support advantage. As Willie called out, Quadro Sync 2 can be used for those of you that want to offer VizSim solutions that go beyond 8 displays. The cards, of course, are VR ready. I should point out that the NVLink implementation here is a little bit different than the NVLink in the GP100, primarily to reduce its speed. And it's important to note that if you have NVLink connectors with the GP100, they will not work with the GV100. You do need to buy the newer NVLink connectors specifically designed for use with GV100. In terms of board power, very little change. It went up 15 watts, but the fact of the matter is, given the performance capabilities, you're getting far better performance per watt. The physical size of the cards is the same, so those of you that are integrating GP100s into systems, in essence, will find that the GV100 is a drop-in replacement. You don't really need to worry much about power supply, thermal considerations, or physical and mechanical size or placement of connectors when moving from GP100 to GV100. So those of you in the system builder, system integration space, very clean transition path that you can offer and bring products to market. Next slide, please. So again, across all of these different markets, the GV100 really does allow you to go in and sell a completely redefined solution. Through AI, the Tensor Cores, it's important to call out that using the GV100 means that you have access to NVIDIA's entire ecosystem of deep learning tools. The same tens of millions, if not more, that NVIDIA has invested in deep learning software stacks for the DGX Station, the DGX1, and the DGX2 are also fully optimized for the Quadro GV100. The same with third-party, be they Google, for example, or Café. Their third-party deep learning, machine learning framework optimizations come for free with this card, which allows you in the AI space to iterate and innovate faster, and due to optimizations using the Tensor Cores, dramatically reduce the training time, the amount of time it takes to take an AI application and get it ready for deployment. In rendering, with the FP32 performance and the GPU memory, simply lets you do things you were not capable of doing before. We're going to discuss how AI can even accelerate photorealistic rendering in a moment. You can also use this for neural network character animation, which has been tremendously labor-intensive in the media and entertainment space. And you can apply AI to analyzing simultaneous video streams. This could be of interest in military, defense, or for that matter, security applications. In compute, high-performance compute, particularly CAE, work with huge data sets, integrate simulation across every phase of the design workflow, utilize generative design algorithms to optimize designs. Quite frankly, the fastest computational finite element analysis, fluid dynamics, or computational electromagnetics available today. In the VR space, all of NVIDIA's hardware VR optimizations are built into the GV100 GPU. Full VR work support is there, giving developers the chance to develop new AI-augmented technologies, or for companies like NVIDIA to advance the state-of-the-art with their holodeck technology. And again, with NVLink, the ability to fuse two physical boards into a logical entity to essentially scale performance. Next slide, please.
Hi, Carl. Before we go to the next slide, I'm going to mute the lines again so you can unmute yourself, too.
Okay. Thank you, Willie.
Hi, Carl. You back?
Yes.
Okay. Let's continue.
Another thing about AI is a lot of folks think of this as something you deploy in the cloud, and there you use things like, DGX1 or the recently announced DGX2 and massive, data farms. But there's also an opportunity with the GV100 to do what they call inferencing at the edge. At the edge is a phrase that's being used in AI. The easiest way to put it is at the point of activity. The example I'm showing here is actually a workstation with the GV100 communicating with multiple video cameras that are monitoring the behavior of a shopper. This is actually being done by Deep Blue technology in China. China, by the way, is a formidable power in AI research. The U.S. and China are very actively engaged in what I'd call co-opetition in that space. And it basically tracks the shopper's behavior and can automatically generate checkouts. So rather like Amazon's, cashierless stores. The other thing it's capable of doing is determining what products a consumer looks at and doesn't elect to buy. So they can track your behavior as well as, generate a receipt. Using the capabilities of the GV100, rather than have to take the video streams, send them off to a cloud hardware implementation somewhere, you can put a system locally in store that does the inferencing at the point of activity. Later, that data could be shared with the cloud to do, big data, deep learning analysis. It's important to note, as I kind of alluded to before, that from a cloud perspective, the entire NVIDIA development stack from the GV that's compatible with the GV100 also works with DGX Station, DGX1, DGX2, all the way through NVIDIA's GPU cloud. So you can offer GV100-based solutions to your customers with the full promise that they will fit flawlessly and without, minimal changes, if any, into deep learning, machine learning, AI systems that are deployed across the cloud in production environments using NVIDIA's technology and third-party, cloud providers such as Google, Amazon, or Microsoft. Next slide, please.
Hey, Carl, and can you just let them know how to access all the frameworks and the Jumpstart information for development? It's free. You can just log in into the NVIDIA GPU cloud and create an account, and they already have everything ready for you. So if you're not familiar with the website, just Google NGC, and it will take you to NVIDIA's cloud link.
Yeah, and they do ask you to register because they want to know who out there is interested in AI, but the information they ask for is a basic contact information and what area of interest you're going to use the AI for, but the software downloads themselves are free. The point to make here is NVIDIA has taken open source frameworks and invested a lot of their own engineering time and money into optimizing and tuning those for the Volta architecture, starting with the GV100s and again working its way up through their AI deep learning product stack. So that's an extremely powerful resource, and the fact of the matter is you could, if you didn't have NVIDIA doing that work and you had a company that wanted to get into the AI space, they could quite easily find themselves taking open source frameworks, spending hundreds of thousands of dollars on NRE to, de-glitch them, debug them, optimize them for their hardware platform. With GV100, NVIDIA has already done that work, and you buy the card, you get the benefits of that for free. Next slide, please. The inferencing performance of a GV100 relative to the GP100 is significant. If you look at Tensor RT, which is NVIDIA's optimized Tensor AI development framework, you look at batch size. As the batch size goes up, you can see a wild performance divergence between the GV100 in green and the GP100 in turquoise. And that's primarily due to the larger amount of GPU memory. Some of it is also available due to the Tensor Cores. NVIDIA Tensor RT is one of those development tools that NVIDIA has provided, that if you go to their developer page, you can download, or your clients can download and start working with immediately. It really provides an optimized set of libraries for doing the inferencing at the edge to pre-process and implement AI at the point of activity, and also sharing the results with the cloud for further analysis. Next slide, please. In terms of training is the amount of time it takes to get a neural network up to speed, where its accuracy is acceptable for deployment in a production environment. Here I'm showing Caffe, which is a third party. It's an ISV, AI development, deep learning development framework, and TensorFlow, which is actually Google's, using a benchmark known as ResNet 50 training. And again, if you look at batch size, due to the increased amount primarily of GPU memory, significant performance advantage for GV100 in green versus GP100 in turquoise. TensorFlow, simply because of the batch size going up to 512 as opposed to 256, it wasn't even possible to get that to perform adequately on the GP100. So again, up to 2x improvement in training performance. The faster you can train an AI or deep learning system, the more quickly you can deploy it, or if you need to make maintenance updates to it, the more quickly those can be implemented. So this will be a huge selling point for folks looking at GV100. Next slide, please. In terms of raw deep learning performance, depending on what you're doing, you can see up to a 2.66-fold performance improvement relative to the GP100. The best results were actually obtained with NVIDIA's own Tensor RT. You'd expect that since it's been rigorously optimized by NVIDIA. But again, the results are not subtle, so folks that are doing AI development will, in my opinion, very rapidly want to migrate from GP100 to GV100-enabled solutions. Next slide, please. Now let's shift gears a little bit and talk about rendering. And, NVIDIA has had a goal for over a decade, the ability for creative professionals, designers, folks in M&E, architects in AEC, to dream and create at the speed of thought, to have the computer and the tools simply get out of the way of the creative process. This spans multiple disciplines. Certainly in AEC, architectural designs, we now have the ability to visualize cityscapes or urban street scenes in photorealistic detail. product design, which spans pretty much all of manufacturing. You can use physically based lighting and materials in real time. In M&E, you can basically get every shot right the first time with GCI accelerated and AI enhanced rendering, all while working at full fidelity, massive data sets, and do things interactively by bringing AI in addition to traditional rendering technology. Let's go to the next slide. Interactive ray tracing has been a long-sought goal. Ray tracing has typically had to be used offline. If you go back to the days of the original Toy Story, you know, it took an entire room full of servers, racks and racks and racks of Intel-based systems to do the offline rendering to create that movie. The long-sought goal realistically has been doing it interactively, doing it in real time, and still having all the lifelike subtlety, nuance, reflection, shadows, textures that only ray tracing can provide. It's been, quite frankly, too demanding for interactive workflows until the advent of the GV100 and some accompanying NVIDIA technologies. Let's go ahead and go to the next slide and we'll start discussing those. NVIDIA introduced at GTC earlier this month RTX technology. As I indicated, this has been over a decade in the works. It's highly refined algorithms. It's developing extremely powerful GPUs that enables, for the first time, photorealistic ray tracing in real time on Volta GPUs. So Volta is kind of the GPU architecture. The RTX technology layer sits on top of that. The optimized ray tracing algorithms, the AI, the deep neural networks that have been trained to accelerate the rendering process. Above that sits something called NVIDIA Optics, which implements additional AI and specifically a denoising feature. One of the nice things about optics, by the way, is it works great on GV100, but it's not tied only to GV100. It'll work even on cards like Quadro P4000 and up. It's important to note that NVIDIA has implemented this in such a way that you can drop in, additional graphics frameworks. For example, I've shown Vulkan. They've worked very closely with Microsoft so that their rendering DirectX ray tracing API, DXR, is fully supported, and NVIDIA DesignWorks, which are the professional development tools for the Quadro space, as well as NVIDIA GameWorks, which are corresponding APIs for game development, are also fully supported. So you've got an entire software stack sitting on top of the Volta GPU architecture. Probably the standout feature shows up in optics. So let's go to the next slide. Optics has the ability to denoise ray traced rendering. I hope you can see the difference between the far left frame and the frame in the center. I know WebEx does a fair amount of compression. I can see it, so I hope you can as well. With denoising on, after 20 iterations, on the left side of the screen, you see what looks like essentially a photorealistic image of a portion of a Camaro. It has metal, it has glass, it has chrome, and it looks lifelike. If you go over to the middle image after 20 frames with denoising off, it's still speckly. I mean, it looks good, but it's not quite there yet, particularly in the glass. The glass looks like it was sandblasted. The ray tracing simply hasn't had time to go in and fill in all the details because it's been having to do a tremendous amount of math. Basically, optics utilizes deep neural network technology that NVIDIA has trained to fill in the blanks, and it will deliver, after only 20 iterations, what in the past would take up to 290 iterations without the denoising technology. So this is one of the key reasons you can get the high-quality results with fluid visual interactivity, and it's a classic case of how AI and rendering are merging to provide previously unavailable and unheard of capabilities. Obviously, on a high-end workstation, this matters because time is money. Let me briefly point out that on a portable computer, it's also hugely important. So a mobile workstation like our Prevail Pro, this has a huge advantage for battery life. because it takes a fraction of the battery to do 20 iterations as opposed to 290. Next slide, please. NVIDIA has been working with all the leaders in this field, so V-Ray, Redshift, Clarice, Final Render, Arnold Solid Angle, SolidWorks with their Visualize. They're working with Autodesk. It's literally a who's who. If they're into GPU rendering, they are tremendously interested in the optics AI denoiser technology, which NVIDIA provides as APIs and developer frameworks to the rendering community. So you'll very rapidly see this productized across most of the major GPU-accelerated rendering products. Next slide, please. Here, I just want to show you the ability of the Tensor Cores that are in the GV100. That is why you see the huge performance advantage that GV100 offers over the GP100 or other Pascal architecture Quadro cards when using this feature. Now again, I mentioned it works its way all the way down the product stack. P4000, even P2000 will show a performance improvement. But here's an example of where the Tensor Cores really show a standout leap. Next slide, please. In terms of rendering performance, if you're using CATIA live rendering in manufacturing, or perhaps you're using Chaos Group V-Ray in AEC or media and entertainment, you can see results that approach 50% faster than the GP100. Obviously, you have the ability to scale multi-GPU configurations, and again, you see a fair amount of scalability even in those. Could we go to the next slide, please? SolidWorks Visualize is a companion program that takes SolidWorks files and turns them into photorealistic renderings using GV100 with NVLink up to 29 times faster than what you could achieve on the fastest currently shipping Intel CPU. Again, time, money, reducing time to market, getting a better product to market, exploring more creative options. All of these are things that the GV100 enables. Next slide, please. Here I wanted to drill in a little more detail into Chaos Group V-Ray rendering performance. I start at the P5000, so we're looking at the high end of the Quadro product line. If you normalize P5000 performance to 1, the GV100 is nearly 3 times as fast. If you scale it, it's nearly 5.4 times as fast. Next slide, please. Redshift is another very popular rendering application. Again, we'll start at the P5000, a little over 2 times as fast. And again, if you were to scale it using NVLink, 4 times as fast as a P5000. So again, huge performance improvement to be had. Next slide, please. If you look at Spec ViewPerf, I wanted to put in a graphic example, up to 1.3 times the performance overall from a Spec ViewPerf perspective than the GP100. The optimizations have primarily been focused on AI, FP64, and rendering. But still, there are use cases, OpenGL, classical graphics, where you could justify the incremental expense of a GV100 over the GP100. Next slide, please. Now we're kind of going to dip our toe into simulation. Simulation is really what you start doing after CAD, and computer-aided engineering consists of primarily pre-processing, which is where you take the mesh that your CAD software develops and you look for any artifacts in that mesh that would cause it not to work correctly with your machining equipment that you're going to use to actually fabricate the components that go into a given product or assembly. That's known as pre-processing. A variety of products do it. Once you've done that mesh optimization, you need to simulate it. I'm going to use an automotive example, specifically the safety cage in a car. Will it actually protect the passengers within the safety cage such that it would meet government or other regulatory requirements? Once you've actually built a physical article and tested it, you want to compare the results of the real deal, so to speak, to your simulations, post-processing. These are all things that you need tremendous amounts of FP64 compute performance to do, and the GV100 delivers it. So those at the high end of CAE will very quickly gravitate to this card. Next slide, please. Why would they want to do it? Well, one is simply the ability to bring designs to market faster. I'm using an example of computational fluid dynamics, where you basically see 2x the performance improvement. You can scale it to 4x the performance improvement. You see the linearity there. That is using NVLink. Another is cost. Abacus is a very popular CAE application. They use a token-based licensing scheme where they charge you based on the job you're doing on the number of tokens required to get it done. You could use 16 CPU cores. You would end up requiring, for one of Abacus's standard benchmark models, 16 tokens. It would cost you $52,000 to run that job. You could say, well, why not boost the CPU cores? You could certainly do that. Go up to 32. You're now up to 21 tokens. If you look at the hardware cost, the token cost, you're up to $69,000. Due to the way Abacus licenses their software, the GPU actually only counts as a single core. You've taken the cost all the way down to $47,000 when you combine the hardware and the token software cost. So you could literally find scenarios where running a single CAE job would more than pay for the cost of the GV100. This is no small thing to people in the CAE community. Could we go to the next slide, please? Here, we'll quickly go through some additional examples. Here's ANSYS Mechanical 19. This is their power supply module test. If you see a 4-core CPU, normalize that to 1. You can see that we can go up to almost 4 times the performance with 8 CPU cores plus a single GP100. Dramatically better performance, using just a single GV100 and 3 CPU cores, and only the same license, so you're getting much better performance at the same cost. Next slide, please. This is actually a simulation of a turbine blade used in a jet engine. Another example of ANSYS 19, a thermodynamic as well as a mechanical degree of freedom simulation. You see a very similar story where GV100 simply leaves CPU-based solutions far, far behind. Next slide, please. This is a computational fluid dynamics example, a pipes model, very complex, many degrees of freedom. And again, the green bars show what you can achieve with GV100 working with CPUs. The blue bars show CPU only. Again, GV100 delivers dramatically better performance across the board, even when utilizing the same licensing packs. Next slide, please. And here's a water cooling jacket, another very complex model. Again, a very similar story. So pretty much across the CAE spectrum, the GV100 is the card you'd like. Let's go to the next slide. Finally, for those folks that use Abacus, Rolls-Royce was kind enough to provide a model that we were able to benchmark. Abacus uses the token-based licensing scheme I discussed before. Using this Rolls-Royce model, you can see the huge performance advantage. 9 tokens with the GV100 versus 8 CPU cores utilizing 12. If you scale all the way up to 32 cores plus a GV100, basically over double the performance of the CPU-only configuration. Next slide, please. This is probably the most complex model of all. It's an elastomeric bearing. The number of degrees of freedom in this is very high. It's very complex to do computationally because an elastometric material has very complex behaviors, highly nonlinear behaviors. Look at the green versus the blue. If you're designing this kind of stuff, you simply need a GV100 to be competitive. So those of you that are selling into this space can make a very powerful, very compelling story for why your customer base should adopt a GV100. Next slide, please. If you're looking at the ultimate VR experience, suffice it to say the GV100 gets you there. The photorealistic graphics with the AI-accelerated rendering, the interactive physics, which is highly compute-intensive, the ability to put avatars and monitor their behavior in real time enables collaboration. All with GPU-accelerated AI a large of the way. The 32 gigs of data means larger data sets than ever before, which basically lets you deliver an absolutely unconstrained and unprecedentedly real NVIDIA holodeck experience. So folks doing design reviews that have, global or, continental teams or need to bring in multiple companies located at disparate portions of the globe and do design or product reviews, holodeck technology and VR is enabled by GV100. Simply put them all in the same virtual room with as close to a lifelike experience as is currently technologically possible. Next slide, please. Finally, a few of you may be selling to scientific and technical markets. Here, you will also see a tremendous performance advantage with GV100. Linear algebra is one example. cuBLAS is an example of a CUDA-optimized routine to do that. You see nearly a 2x performance advantage using GV100 because you can drop to FP16 performance as opposed to have to use traditional FP32. Labs does atomic modeling. You see a little over twofold performance improvement on GV100. AMBER is a molecular dynamics and modeling package. Here you see a little over, actually about a 1.65-fold improvement. So in science and technical markets, universities, research institutions, government labs, if you sell into those type of environments or work with them, there's a very powerful scientific and high-performance computing story you can offer to your clients as well. Next slide, please. Obviously, we've been focused on the high end, the GV100. But bear in mind, across the entire Quadro product line, you've got a scalable range of products from the P400 through the mighty GV100. Disciplines from AI to AEC, energy, manufacturing, media and entertainment, or medical. So you still have the other Quadro products, but if you're focusing on AI or you're at the extremes, at the limit of what is possible in AEC, energy, manufacturing, M&E, or medical, GV100 really is a very fine addition to your solutions arsenal. Next slide, please. I also want to point out that we're not asking you to do this all by yourself. We have marketing materials now that PNY offers to drive your sales. We call it the GV100 Sales Zip Kit. It includes a very nice data sheet, updated Quadro product line card, sales and marketing copy, features and benefits copy, technical specifications. We have an extensive product photography library in JPEG, PNG, and TIFF. JPEG and PNG being optimal for web, TIFF being ideal for print. We also have web banners. We've even developed mini X stands so that if you're going to shows and events or you just wanted to do some, marketing to make it obvious that there's a GV100 in your product, we've got these available, and you can contact your PNY account manager for advice on how to get a hold and utilize those. I also want to encourage you, if you're not already a member, to join our authorized partner program, which gives you access to a portal which makes all of these assets literally just a password and a click away. Finally, on the next slide, our most important asset, our sales and FAE team throughout the Americas North America, Canada, actually into Latin America as well. We have dedicated territory managers and team them with inside sales representatives. Willie Ortiz is our field sales engineering manager. We also have Mahendra Borat, our Quadro FAE. And we have general sales inquiry assets, go PNY at pny.com. We've also got the PNY Partner Program I alluded to before. So PNY as a company is ready and willing to partner and work with you as you identify and close GV100 sales. So we don't just want to offer you a price list. We want to get involved with you in terms of qualifying the opportunity and helping you close the opportunity, and even work on the technical feasibility, and perhaps do pre-sales, post-sales support with folks like Willie and Mahendra.
Yeah, and thank you, Carl, for adding that. Yeah, like Carl said, we're here to help you out. Feel free to use us as a resource if you need a conference call with your customers, or if you just want to integrate the solution, you need a step file, thermal reports. Once you integrate it, you sell it. If you need certifications, export data, anything you need, we are here to assist you with that effort. Once again, use our resources. We have a complete team of professionals that specialize in the graphics industry that have many years of experience, and a whole technical team to assist you as well. If we don't have any other questions, we will end the webinar. But if you think of a question, or once again you need any other information, you will get this contact information for your sales representatives or the technical team. You always can email us at gopny@pny.com. And we want to thank you for your time. I know it's valuable to attend this webinar, and thank you for attending.
Let me echo that. We do value your time, and Willie and I both appreciate your willingness to share it with us. Thank you very much, and good selling.